the room, and also a pretty good crowd online. So thank you all for joining us. As you all know, this seminar series is funded by the Matthew Tabek Memorial Lecture Fund, administered through the Division of Geriatric Medicine. And we're very grateful to have their support. And I do believe we have enough support lined up for next year. So it's time to start thinking about which external speakers you want to invite in, and we can cover their expenses as well as give them a small honorarium. So please start thinking ahead for next year. And you might also think ahead as soon as next month. The next meeting of the scientific seminar series is 4 weeks from today, Monday, April 4th. And we, as of right now, do not have a speaker lined up for that date. So unless you want to hear me come and volunteer to speak or recommend speakers that I can talk into presenting on April 4th. Today, we're very fortunate to have our own Alden Gross as the speaker in the seminar series. Alden has been with us for a number of years. He got his bachelor's degree from the University of Maryland in College Park with either 2 different bachelor degrees or a double major. One area of expertise is psychology, and the other was neurobiology. After that, he enrolled in graduate school here at Johns Hopkins, getting an MHS in mental health, then an MHS in biostatistics, and then got his PhD in the Department of Mental Health. After that, he went on and did a postdoctoral fellowship at the Institute for Aging Research and the Hebrew Senior Life Center of the Harvard Medical School, where he worked for 2 years up there, working with a lot of great folks. And then after that, in April of 2013, or on thereabouts, somewhere in 2013, he joined the faculty here at Johns Hopkins in the Department of Epidemiology with a core faculty appointment in our Center for Aging on Health. Alden has really done terrific work since joining our center and even throughout his training. Just a few highlights. He has over 160 peer-reviewed publications, and for someone who got a PhD in 2011, indeed his first publication is 2010, that's 160 publications over just over 10 years. So you can do simple arithmetic and determine that that's a very high rate of productivity. He also is very well funded and is about to get some new grants, one in particular becoming a new multiple PI on the very important and prominent Global Gateway on Aging funding for a study. So today, I believe Alden is going to talk to us some about that study and some of the work he's already done. He has expertise in cognitive aging and harmonizing cognitive data in particular across numerous different studies so that they can be combined into larger data sets for more powerful and informative analyses. So the title of Alden's talk is Measurement and Structure of Cognition Across the World, Statistical Harmonization of the HCAP Studies. Welcome, Alden.
Thank you. And some work on education. Let me see I've got it here. So first thing I want to do, I want to apologize for today. I have a little bit of a cough and the sniffles. Promise in this day and age, it's not COVID. Instead, I have these guys. And toddlers give you lots of illnesses, and they are also the reason why the knees on all of my trousers are scuffed up. And so there's that. But anyway, this is my family. And speaking of family, I was just looking out in the room here. I haven't seen the people on Zoom, but maybe 80 to 90% of you I've been in Zoom meetings with. And you know, family is really important to me. And this is the backdrop of all my Zoom meetings that you guys have seen. These are not all mine, but education has been important to me and to my family for a long time. And having these degrees up is a way of acknowledging those who came before me. This is the snapshot from the first page on my dissertation that I published generations ago. It all started with this guy. He was my grandfather, and he always told me, don't let school interfere with your education. He was big on making sure that you learned, and that if schooling became a problem, don't worry about it. Just make sure that make sure that you keep learning. This degree, I think he got it in 1973 and he was born in 1919. So do the math on that. He was a lifelong learner. Part of what made his story so remarkable is partly because of where he came from. He was the oldest son of a Nebraska farmer. This is his dad, Stanley, who wanted nothing to do with book smarts or anything that was not from the farm. He despised educations because that's what government bureaucrats had, and that's what bankers had who took the family homestead in the 1940s. And so, yeah, so his story was pretty remarkable and impressive, I would say. Anyway, a common question that we might ask, transitioning into the talk now, as an epidemiologist and a gerontologist interested in cognitive aging, how important is cognition, is education to your cognitive health in later life? So was Everett's education and his lifelong love of learning protective of his cognitive health in later life? He went on to be in his late 80s and never had a hint of dementia. More generally, so this ends up being a controversial causal question, and it's more controversial than it looks like on its face. I think that, those of us in this room and in the Zoom are all in the boat that more education is great and good and all. I'm pretty sure all of us have a bunch of degrees, but there's important selection effects that happen between an education, which is usually acquired in early life, and cognition in later life when you measure it decades later. And also there's heterogeneity in what education means, both in the US and as we'll talk about elsewhere. So here's a study from, I think, 2018, where this was a simulation study. It was great. We didn't have to use any data. And the point of this study was to demonstrate that depending on depending on the magnitude of selection effects, your ability to estimate a true effect of education on the rate of cognitive decline can be way off. It can be highly attenuated depending on how much education is related to mortality. So there are these common causes and selection effects that preclude our ability to measure effects of an exposure on cognitive decline when that exposure is measured super early and when that exposure is also related to mortality. So it's a problematic thing. Another challenge is how do we quantify education in the US? Oftentimes we fail to recognize heterogeneity in what a year of education means. And it varies a lot by the year one completed your schooling, as well as race, as well as location. This is an oldie but goodie. I think this paper is probably from 2008. The y-axis is the average number of days in a school year. And the x-axis is calendar year, spanning from, looks like 1919 until 1951. Sorry, Monique, I stepped away from the laptop. And then the lines are different race/state categories. So if you were white and had your education in New York, the average days in a school year was pretty consistent since for most of the 1900s. Whereas it's changed dramatically for places, particularly in the South, like South Carolina and Alabama and so forth. So these are things to keep in mind. And when we're thinking about education and how to measure it within the US. So if we can ask, was Everett's education protective of his cognitive health in later life? Is our answer comparable? Is that generalizable if we were to look outside the US to other contexts outside of the United States? Here's another woman. She was born in somewhere in the 1920s also. She was born and she still lives in India. Miss Maror. She's my grandmother-in-law, and she was married at 18 years old never had a formal education. Her husband died when she was 35 years old. She was too illiterate at the time to sign her own name to deeds and documents. And she ended up having 8 children before her husband died. But even though she never had an education, she made darn well sure that all her kids got bachelor's and master's and other degrees and stuff. So, you know, they seem to be doing fairly okay now. Did education help improve this family? And did it improve their cognitive functioning? Well, she just survived COVID last month, so I don't know, maybe there's a correlation. So, you know, the question that we have here, how important is education to cognition in later life, both in the US, and is there any conferred benefit that's present across different parts of the world? From gerontological and psychometric perspectives, thinking about measurement and the science, these are really, really hard questions that we ask, but they're also super duper important questions. The prevalence of dementia and cognitive impairment is increasing exponentially, largely due to increases in population structures around the world, leading to elevated economic, social, emotional burden on communities and families. And up to about 40% of dementia cases might be preventable via modifiable risk factors like education. And so the reason this is important is if it can be shown that a risk factor like education, which is inherently modifiable, if this influences dementia risk across contexts, this would strengthen causal claims and thus facilitate potential intervention targets because education is potentially modifiable with time. So here's the snake diagram. Doesn't show up so well on this slide, but you guys, most of you should be familiar with this diagram that shows the potentially modifiable and non-potentially modifiable risk factors for dementia on the bottom here. It's a popular diagram that the Cochlear Center shows because there's hearing, which holds 9% of the modifiable risk for dementia, but then there's education up here, which is even earlier, which is projected at 8%. So regardless of what the percentages are, it's a potentially big deal. And we know that education has other benefits too. So, you know, it's not like we're losing a lot by promoting educations. Another facet of this study, and the reason we're interested in looking at international effects is about 75% of Alzheimer's cases are expected to occur in low and middle income countries by 2050. And despite this fact, very little AD research is being done in these regions. It's estimated about 10 to 20% of research dollars are going outside the US and Europe for Alzheimer's research. This represents a major missed opportunity to identify individual level and contextual influences on later life cognitive functioning. So how do we approach these questions? Here's one way that I'm going to talk about today. There's this project called the Harmonized Cognitive Assessment Protocol, the HCAP networks, which were funded in 2015/2016. They got the funding and then it took a couple of years to get off the road in different countries. But this is basically an NIA-funded international research collaboration to measure and understand dementia risk by collecting a common set of established cognitive instruments using the Health and Retirement Study and its international partner studies. So you guys are all aware of the HRS States. Somebody's unmuted. You guys are all aware of the HRS in the United States. The HRS also has like 20 or 30 different international partner studies around the world, from China to Indonesia to England to the rest of Europe, Mexico. Several of these HRS partner studies have administered these HCAP batteries, which is basically It's a subset of the studies that administered more detailed cognitive batteries that lasted between 1 and 2 hours, about 70 to 80 minutes per battery. The batteries that I'm going to be talking about today are HRS-HCAP in the United States, MEXCOG in Mexico, Halsey in South Africa, Lacidad in India, and ELSA-HCAP in England. In the next couple years, coming online, we have data that have been collected but stopped due to COVID in Chile. Charles HCAP in China is available. There was recently, as of like a month or two ago, an HCAP funded for Kenya. So we're going to be collecting data there, as well as we've got studies in Ireland and Northern Ireland that we're going to be conducting and gathering data in. So it's a lot of fun stuff. Here's some study characteristics of the studies that I'm looking at today. As you can see, in these 5 countries, these studies were conducted between 2016 and 2019. The sample sizes range from as little as 607 folks in South Africa to 4,096 participants in India. The US kind of set the benchmark at 3,300 participants. And then India, the PI there, Jinkook Lee, just kept adding participants in subsequent phases. She stopped at 3,000 and then she said, I'm going to go up to 3,500 and then I'm done. And then she got some extra supplemental funding and she kept going and going. She's a real go-getter. So she kept adding several different states. And importantly, in all of these countries, with the exception of South Africa, these participants were selected and so that they could be so that they can generate weights so that you can generalize estimates to the national population of older adults. Response rates were pretty high in most of these places. The mean age in the US was 76, similar in England. It was younger in India, Mexico, South Africa, primarily because the minimum age of recruitment was lower in those countries. There just aren't as many older adults, 65 and above, in India, Mexico, South Africa. So they started at like 50 and above or 60 and above. The percentage female was between 55 and 60% in all of these contexts. And I have in the last column, I'm showing the number of tests in the cognitive battery. I should clarify that these are the numbers of test items. So, you can have a test, like a trail making test, but then I'm concerned, as I'll talk about shortly in grave detail, I'm concerned about test items. So like a trail making test has a part A and a part B. So that one test has 2 items. So on average, I think, I'll say that I'll make up a number and say between 10 and 15 tests. But those 10 and 15 tests break out into around 40 to 45 items in each country. This is a list of the tests. And so there's a row for the test name, and there's a column for the country where it was administered. And so, one test is at the very top is the mini mental state examination. Of course, we will break that out into 19 different subtests. And that's what the mini mental state examination is. It's a 30-point test of 19 items, but the individual test items are like, what's the date? What season is it? Who's the president or the prime minister? These can be considered individual test items that you can use. We have the other heavy hitters include the CIRAD word list recall task, which has an immediate and a delayed and a recognition trial. So these are sub tests of it. There's animal naming and so on and so forth. And excuse me, the HCAP batteries the HCAP battery was designed to be comparable as possible across these different contexts. But there were some deviations as we'll talk about in a little bit. Yeah. Where do you see that?
H, Y obviously means yes, but what does H
H means harmonizable. This, potentially harmonizable. So that, for example, the MMSE row in lossy, technically, and this is so that psychological assessment resources, PIR, won't come and sue the study. Technically in lossy, they administered what's called the Hindi mental state examination, HMSE, which some of the items are a little bit different. So it's not formally the MMSE. And MHAS has the same MMSE items, but Rebecca Wong at University of Texas right now is kind of terrified because away from the audio. She didn't pay for the license fees. Okay. But yeah, and then Halsey. So up here, you'll notice there's only 31 items in South Africa, the Halsey study. They actually administered a lot more, but they're not even distributing their MMSE items because they're afraid of licensing fees. This is a whole other issue in cognitive aging. Around 20 years ago, individual researchers like Jason Brandt and Marshall Folstein started selling their tests to companies. And so that's kind of thrown a wrench in things. If anybody's a lawyer or knows a lawyer who wants to take on this, that would be great. But anyway, let's go on. So this data have been collected. What's been done so far? So far, there have been individual analyses in individual cohorts, and at times there have been coordinated analyses in these different studies. And these studies have separately shown that a similar hierarchical factor analysis of the cognitive abilities fits pretty well. So I did a 2020 study of the factor analysis in Lassi Dad in India. Miguel Ars published his 2021 paper in Mexico. Rich Jones is still working on his HRS HCAP factor analysis. And we're also working presently on the ELSA HCAP factor analysis. As I mentioned before, and I'm going to keep mentioning over and over again, not all of the HCAPs administer the same items, and there were various language and cultural factors that drove those decisions. There are also issues with literacy and numeracy in some of these contexts that were not considered in the United States context. Because not all of the batteries were exactly the same, and because even if a test might be exactly syntactically the same, there may be scoring differences, or there may be other reasons why a test may not actually be measuring the same thing in different contexts. Because of all these things, we need statistical harmonization methods for cross-national linking. And so that's what I do. So that's where I come in. So what do I mean by a hierarchical factor analysis? Well, it conceptually kind of looks like this, where we take a bunch of the items. These are the items for Lassi Dad, just because I have the slides available. These are all the items in rectangles, and we make latent factors, which are in the circles. So for example, orientation is comprised of the common variability among all of the orientation sub-items, like what's the month, what's the year, what city or village are we in, and so on and so forth. In order to build this big model here, we start with each individual factor. So we develop a factor and get a good fitting model for orientation, and then memory, and then executive functioning, language and fluency, visuospatial ability. And those are kind of our domains. We look at the fit statistics. I won't go into, I don't think we have time to go into great detail, but essentially I've got a descriptor in the last column showing what I'll say is to indicate that these models fit either good or perfect or adequately. ultimately, the multi-domain model, both in India and the United States, fits adequately and they have very similar fit statistics. So what does this tell us from a psychometric perspective? This tells us that we've got configural measurement and variance across at least these studies in the HRS, HCAP, and LACIDAD. And I can tell you we've found similar findings now with respect to ELSA HCAP. So that's cool. This is something that we don't necessarily want to assume a priori. For example, I think we can all agree that memory as a construct exists everywhere. But what about visuospatial functioning? Does that construct exist in the same manner across different cultural contexts? Actually, going back to memory, there are cultures outside of the US which are very big on that have very strong oral traditions. So the way you assess episodic memory, one of the ways is a story recall task where I'm going to read you a story about Anna Thompson of South Boston, had 3 kids, and she was robbed one night, and she went to the police, blah, blah, blah. And then I want you to recall as many of those details that you just recalled. It turns out that in pilot testing, when you administer that test in India, not every older adult, but a lot of older adults will be like, what story? Oh, that story? That's a terrible story. Let me tell you a better story. And then you'll get this participant who's going to just elaborate and tell a better story in his mind, because that's the culture, that's the tradition. They're not regurgitating things like we do on our multiple choice tests in school. But anyway, at the end of the day, between HRS, HCAP, and LACIDAD, and a couple other places, we've got good cross-validation of our measurement model. There are differences in indicators that are largely trivial for this stage of analysis. And so, that's fine and good and all. But when it comes to statistical harmonization, this is the point at which we really want to pool the studies together and go through a bunch of steps. So I'm going to talk about the considerations that we go through in pre-statistical harmonization, and then I'll briefly touch on statistical harmonization approaches as well as diagnostics. And then we're going to use our derived scores for inferential models. And particularly, I'm going to use our harmonized cognitive scores that we've been working on for a bunch of years now to look at relationships with education. And how do we harmonize education? That's a whole other talk, which I'm just going to blow through in like one quick slide because David wants me to leave by 4:30. So we're good. Pre-statistical harmonization is so complicated that fortunately I have this colleague. She's awesome. She's at Emily Brisenian. She's at University of Michigan, and she wrote a whole paper on it. She's the expert on pre-stat harmonization now. So basically, in pre-statistical harmonization, the goal is to go through all of the tests in every battery, and we're trying to understand how the tests were administered and how the tests were scored. This is pre-statistical harmonization is pretty easy to do when you're dealing with cohorts like within a country or within a single language. Basically, I used to do this just in my office. I'm looking at test names and I'm looking to make sure the minimum and the maximum scores in the data set are at least similar, right? I can't really do that. Alden Gross can't do that alone anymore and be believed. Many of the HCAP tests were designed to be comparable, and they were doubly translated, etc. They were designed to be comparable primarily by folks like economists and epidemiologists, not always neuropsychologists. So, there's a reason why on the MMSC, we ask you to, one of the items is we ask you to spell the word world backwards. You can't just translate world into Spanish, that's mundo, and say to spell that word backwards. That's a fundamentally different item. And you really need to find a Spanish word that only has one syllable and that has a conglomeration of consonants, so that you have to really close your eyes and visualize it in order to spell that backwards. Mundo has 2 syllables. It's only got N and D as consonants. It's not comparable, but you need a neuropsychologist to tell you that. But yeah, so in the cross-national sense, we need common test items for linking. So we really depend on that. And Michelle has been involved. This is what our Friday mornings look like. We've been involved in this since, I think, December or so. As I mentioned, due to language and cultural issues, as well as differences in scoring, we can't be certain which of these items might be linking items. For example, we found out the long way that, or the HCAP studies have, you can't really do trail making tests in low and middle income countries. There are literacy issues, there are numeracy issues. It just doesn't work out in practice. There are certain tests that involve stimuli that you see on a page, and you either cross out letters or you circle things. Most of the world uses 8.5 by 11 sheets of paper. England uses A4 size paper. It's that legal size stuff. So what did they do? Did they increase their font? We need the actual, we have to contact their study administrators and figure out what was the actual form that you used. Are words in a list learning task presented verbally, or are they presented verbally as well as in a written form? These things matter a lot. We're not even talking about translations, because we know that's a huge elephant in the room, but there's really no way to tackle that. There are items like, what do you do with a hammer? So this is with respect to scoring. Well, the only accepted answer in the United States to this question is to drive in nails. In South Africa, they were also allowed to say to pound things, in addition to driving in nails. So in that setting, it's kind of easier to answer this question because there are more response options in South Africa than there are in the United States. The scoring makes this a potentially non-equivalent item. So that's fun. Our work on establishing linking items across studies, I'd say we've done 80 to 90% of the work, but it's an ongoing effort. Our approach is that we can conduct diff testing, differential item functioning testing, to determine whether items are truly comparable. Now, I'm not sure I want to get into the whole science or logic of diff testing. Differential item functioning essentially is asking the question, is an item measuring your construct in the same way across different groups? Or alternatively, is there a special relationship between the item and the construct that differs across your different groups? There's a really common problem in diff testing. So think about test items on the SAT or the GRE. You want to make sure that these items are not biased in some way. Synonym for diff is biased, not exactly the same, but it's similar. There's this problem called the constant diff problem. If you administer a bunch of test items, oftentimes, and this happens with race-based diff as well as language-based diff, more often than we'd like, it often happens that certain items are biased in one direction and many items are biased in the same direction to a similar degree. If in such a situation, that systematic bias across multiple items is taken to, it will be mistaken for real differences in the latent trait, as opposed to measurement problems. To combat that, you can conduct diff testing using anchor items that a priori are comparable, that are not different across settings and contexts. We can do this, especially when you've got same language tests for the most part. But at the end of the day, it's really best to conduct diff testing with some anchors. So in our cross-national context, when we know our samples differ with respect to language, as well as numeracy, as well as some of, in parts of in the particular Agincourt region in South Africa, people are not familiar with pencils. That was a novelty. So what could possibly be an anchor in this cross-national context? So we've developed an empirical approach for linking items, and this paper was just accepted in February 7th, so like a week or two ago. Basically, we convene a bunch of experts to tell us what to do. It's great. It's not Alden in a room anymore. So formally, we convene a multidisciplinary team, especially featuring our neuropsychologist friends, and you need people who have cross-cultural expertise and knowledge of the languages. And we've been meeting weekly on Friday mornings, and Michelle is kind of our gatekeeper. And we're deciding, and we're dividing our potential linking items into two groups. The items that we're really confident that these are linking items. And then we're items which might be tentative linking items. For example, what do you do with a hammer? That might be a tentative linking item. But then if I ask, what is this? It doesn't matter. If I ask, what is this? It doesn't matter what language I'm asking you this in. Every language and every culture, everybody has a name for an elbow, okay? That's a pretty confident item. And that's one of the items on the test. So pre-statistical harmonization is a bunch of accounting work. Our spreadsheet has 333 cognitive test items. So I told you that each of these cohorts have 45 to 50 tests. So we're basically reviewing all of these items for their comparability across cohorts. And we're presently re-reviewing them right now. I think we can be finished by May. And we're coordinating with the Gateway to Global Aging group, as well as specific study cohorts. So this is a pretty big effort. We want to make sure that we get this right, because, to be honest, our economists and our epidemiologist friends are happy with the way things already were, but we want to make sure that, we've locked this in so that our psychologists and our really picky people are happy with it, because we're going to distribute these scores ultimately that are going to hopefully be used by a bunch of people. And we want to make as few mistakes as possible. And we really love details. So our approach to empirical identification of linking items, ultimately it matters. So once we take these decisions from our multidisciplinary teams of neuropsychologists, as well as epidemiologists and psychometricians, what we do is we first evaluate. So I told you, we identify items that have that are confident linking items. There shouldn't be any diff in these. And then we identify items, and then so we see if there's any diff present in the confident linking items, we dump out those items, and they're no longer in our diff pool, in our pool of anchor items. In our second step, we evaluate diff in our tentative set of linking items, treating as anchors the confirmed confident items. And in that way, we get around the constant diff problem. And many of these tentative linking items end up showing quite a bit of diff, as you can imagine. And so we drop them out, but many of them don't, and we can retain them as linking items. And then what we do is we evaluate salient diff by basically, you estimate a factor score in your cohorts, assuming that there was no diff. You then estimate a factor score acknowledging that there is diff. You take these two scores and you subtract them. And then you graph the difference. And what I'm showing here in this graph is the difference score on the x-axis. The blue line is this is diff with comparing the factor scores between just the United States and Mexico. The blue line is the United States, and there are these vertical black lines showing sort of bars at plus and minus 0.3 standard deviations, which for various reasons is considered, the technical term is tolerable measurement slop. It's sort of the boundaries between what is acceptable as a big difference. Nobody in the United States is affected by this diff adjustment, whereas in the red dashed line, this is the MEXCOG sample in Mexico, and there's a lot of participants, maybe about 40 to 45% of participants who in this distribution who are at the extreme end past negative 0.3 standard deviations. What that means is that for almost half of the MEXCOG sample, their diff adjusted scores are considerably higher than the non-diff adjusted scores. So this approach to diff adjustment matters, and it has a big impactful it has a big impact on scores. So it's important for us to be careful about this. Anyway, so at the end of the day, we get a full battery, and hopefully our harmonization technique can leverage both items that are unique to a particular study or cohort, as well as items that are in common between cohorts. And so the thickness of these green lines corresponds to the number of items that are in common between cohorts here. So you'll see there's less in common between Halsey down in the lower left here and in most of these other cohorts. There's a lot in common between Lassie-Dodd and HCAP and so on and so forth. So we look for these patterns of overlap across the batteries. In addition to general cognitive performance, we're also doing this for specific cognitive domains like orientation, like memory and language and visual spatial functioning and executive functioning. And so, you know, these are important features. For certain domains like executive functioning here and visual spatial functioning here, you start to see a lot of thin lines. There aren't a lot of good anchors. And in such situations, we've got a tool for that too. When we don't have, when there are not enough common items, either no items or too few linking items, we came up with this solution that makes a lot of assumptions, but we think it's reasonable. It's called linear linking for related traits. So what we do is, instead of leveraging information about common test items between your two cohorts, we leverage information from a related latent construct. So in particular, if you've got a domain such as executive functioning or visual spatial ability, well, all of these cohorts will have a general cognitive functioning construct. And executive functioning should be related to general cognitive performance similarly in across all of these contexts. That's a big assumption we're making. And so for a specific cognitive domain, that's a subdomain, and then your general cognitive performance is a specific subdomain, or sorry, general cognitive performance is your more subsuming domain. At the end of the day, we just published this last year. Emma Nichols, who is my amazing grad student, really drove this effort. So this is another tool in our toolbox at the end of the day. Back to in situations when we do have enough common linking items, this is our general approach to statistical co-calibration after we do our pre-statistical harmonization. So the first thing we do is, in each study, for each domain, we conduct factor analyses. And then we use an item banking approach to co-calibration, which I'll talk about in a little bit. And then we do some diagnostics. So these are our study specific models, and the model fits. This is a busy slide and I apologize, but we have some criteria for determining whether the fit is adequate or good or excellent or not. And for the most part, with the exception of executive functioning, almost all these models fit pretty well. Our item banking approach goes like this. And so I want to spend a minute on this. We start with study one. So let's say that's HCAP. We do this pre-statistical harmonization of items, which involves recoding and redefining items, stretching them out and constraining them as needed, until we get a harmonized set of items. I'm trying to use my mouse to follow along here. That's step 3. In step 4, we use item response theory to conduct a calibration in which we estimate the item parameters. These item parameters include locations of the items along the latent trait, as well as degrees of correlation or relatedness between items and the latent trait. So, in other words, the weights of items and how important those items are for measuring that underlying latent trait. So this is an IRT calibration exercise. From that, we save all of these parameters basically into a giant Excel spreadsheet in step 5. And we call this spreadsheet an item bank. In step 6, so in study 1, we're doing all this work within HCAP. And step 6, we take some other data set, whether that's Lossy Dodd or MEXCOG or NHATS. We take some other data set, we conduct a similar pre-statistical harmonization where we recode and redefine the cognitive test items that we've decided are confident linking items. We do the same actions that we did in study 1 until we get a harmonized set of items in step 3 over at the right here. And then instead of a co-calibration, we do the IRT standardization here, in which items that were common between study 1 or any previous study and this new data set, the parameters for those items are fixed to be the same as they were initially. And any new items that are novel to that study, those item parameters get freely estimated. And those new item parameters get added to our item bank here. At the end of the day, we have this item bank and we can feed any new data. So step 2 here, down at the bottom here, you can take any future harmonized set of items, as long as all of those items are known to us and are known to our item bank, we can feed them through our item bank and estimate latent traits. And so in an ideal world, someday we will know the universe of all potential cognitive items, and we'll hopefully be able to identify all of those items, and we'll be able to generate in the final step, in the bottom right here, a pooled data set with equated latent trait estimates. We developed this approach about 5 years ago with Rich Jones's pitch project, and it's now being applied in a bunch of other consortia, including some blood pressure and stroke and diabetes studies, as well as C4R, which is a COVID-19 consortia of a bunch of NHLBI cohorts. We like this approach because it's readily scalable. We can add more studies to the pipeline as we receive them. For example, I mentioned that Chile they're presently cleaning their data. I don't have their data yet, but it's going to be fairly easy. As you can see, we just add these studies serially and we can build them in, and China will come in a little bit. We conduct diagnostics. Basically, we look at missing data, and we can also look at imprecisely estimated scores. So, there may be a cognitive battery that's administered for everybody in the cohort, but Individuals may refuse a test, or they may say that they don't know or they don't want to answer the test options, and that translates into imprecision in the estimates of the scores. So we can flag those observations empirically from our model. In terms of missing data, interestingly, it's not really a problem in these cohorts. A lot of these cohorts, before we get them, have applied a multiple imputation strategy that's consistent. There's a guy at USC, Eric Meyer, who's doing everybody's imputation. He's awesome. Until Europe comes in, they're gonna disagree. And regarding imprecisely estimated scores, as one would expect, the orientation domain is highly imprecise because the orientation is comprised of asking some very simple questions about orientation to time, what's the year, what's the day, what's the month, what's the day of the month, as well as place. And so, you know, when most people get these items right, you're not providing really strong measurement properties for this domain for people in the higher functioning realm. But memory is okay and executive is okay, and those are the ones we care about quite a bit. At the end of the day, we statistically co-calibrate cognition across our HCAPs, and I'm just going to show you histograms of the scores just to emphasize the ending product are cognitive scores that we can use. Okay, awesome. So we've got some cognitive scores. They can be outcomes in our models when we look at exposures like education and cognitive functioning. So what about education? Didn't I say that's hard to do in the US alone? Well, you can consider percentiles of education, maybe. It's just that maybe you can compare people at the 10th percentile of education in the US with people at the 10th percentile of education in Mexico or what have you. The empirical problem there is 50% of the populations in Mexico and in India have no education, no formal education at all. What we've ended up doing is looking at educational attainment using this international standard of classification of education, ISCED, which this is again, it's something we can reference and it's something authoritative. So we're going to use it. We can group people into early childhood education or no education, primary school, lower secondary, upper secondary, which is basically kind of high school, 10th, 11th, and 12th grade, and then any college. Empirically, we had to group people from vocational school or some college all the way up through PhDs because the US has has most of the postgraduates, and very few countries have much college education among their older adults. So here's a distribution of education across our HCAP samples. As you can see, in the US and England, there are very few people with no or just early childhood education. There's a lot of people with college degrees or high school degrees, whereas the story is different in Mexico, India, South Africa. There's a bolus of participants with no or early childhood education. So, you know, we want to be mindful of these differences as we go on. Here's an overall association of educational attainment with cognition across the HCAPs. This is a simple regression in the whole sample. It's adjusted for age and sex, but it's a regression of cognitive functioning on education. And there does seem to be a sort of a dose-response relationship. We're seeing higher beta coefficients for higher levels of educational attainment. That's potentially good. Let's test our luck and let's look at that association stratified by HCAPs. And so here, I'm showing beta coefficients for each country. And so there's almost relative to having in the US, relative to having no or early childhood education, the benefit of having of obtaining up to a primary education in the US HCAP sample of adults 65 and older is really negligible. There's not much difference. There's a bump once you get to grades 7 to 9. There's a further bump once you complete high school, and there's an even the largest bump is if participant reports any college. Similarly in the English sample, there is a bump. There's a beta coefficient that's marginally statistically significant when you go from no to primary education, but there's a concerted bump, especially as you grow and as the educational attainment increases further. For Mexico, India, and South Africa, the story is a little bit more nuanced. You get a considerable bump right at the start. So there appear to be benefits of even education at even very minimal levels in our low and middle income countries. This may be a cohort effect that's unique to the particular cohort of older adults who are older in the calendar period between 2016 and 2020, because we know that there are some strong graded effects. A lot of younger people in these countries are getting more educations, but right now for the older adults today in these studies, there does appear to be benefits of very minimal education. For another time, we can have a whole other conversation about sex differences. And I have a colleague at Columbia who is finished her analysis, and she's writing up a paper about sex differences in the relationship of education with cognition across these some of these cohorts.
Cognition is how many levels? Like 3 or 2?
Cognition is a continuous score like this. It ranges between -4 and +2. It's on a Z-score scale.
But when you categorize that like dementia?
No, I'm not categorizing cognition. The exposure is education, and the outcome is a continuous cognition. So these are linear regressions, just simple linear regressions right now. And someday we'll add in population weights and weights to account for selection effects, but this is just an initial peek at the data. I've got to wrap up here. In conclusion, how important is education and cognition in later life? These results at least suggest it's pretty important. Is there any conferred benefit that's present across different parts of the world? Yeah, there seems to be. And especially preliminary findings seem to indicate that especially low levels of education have a somewhat stronger relationship with later life cognition in lower middle income countries. So, stay in school, but of course, don't let it interfere with your education. This wouldn't be a good talk if I didn't talk about all the limitations. You guys can imagine there's 20 more limitations than what I've got here. The number one thing is this is a cross-sectional study design. This is a huge international effort, and second waves of these cohorts are planned for HRS HCAP and La Ciudad and MEXCOG in 2023 and 2024. Actually, I think that, no, actually, I'm wrong. India is going into the field in April and May for their wave 2 of their La Ciudad. We're not going to have those data yet, though. It's coming. Education is not the only risk factor. So the Livingston Lancet Review Commission estimates it accounts for about 8% of modifiable variance in dementia risk. Of importance also is hearing, cardiovascular measures, socioeconomic status, midlife and later life measures of all of these things. So this is one piece of the causal pie that I'm talking about here. The ISCAD assignments for education that I talked about are somewhat arbitrary. So, you know, what I gave summaries of what I did without going into the nitty-gritty details. But for example, in China, there's something called a Sishu education. I know I'm pronouncing that wrong, but it's basically a private school education for like primary school. And where you put that exactly, it's a little unclear. So we have to ask a bunch of our experts and people who know the culture. In terms of confounder adjustment, we only adjusted for age and sex. If you're going to adjust for anything else, you have to do your own co-calibrations for those individual variables. But age is pretty straightforward and sex is pretty straightforward. Participants know what those are, and we can be pretty sure that those mean the same thing across contexts. There are definitely interactions by sex that we didn't talk about. There's also a problem of differential mortality across these HCAPs. That's the reason why, especially in South Africa, the cohorts started earlier in age. In the cohorts of older adults, quote unquote, start when you're 50 and older. Some future directions. This is part of there's kind of two R01s that are sort of funneling into this work. Here are the aims for this one project. The first aim of this project that I'm collaborating with Lindsay Kobayashi at Michigan is to statistically harmonize the HCAPs across the HRS International Partner Studies. And that's what we did for the most part in this talk. We're going to be making the code available on the Gateway to Global Aging, and we're going to be negotiating with individual studies to provide user generated data sets on their own study websites. Aim 2 is to look at the contributions of life course SES factors to variation in late life cognitive functioning. I talked about education here because I'm working on education a lot, but we're also looking at occupation, wealth, expenditures, parental education, parental occupation, and marital status. All of these things have been collected in the HCAPs and their parent studies. Remember, these are sub-studies of parent studies. And our aim 3 is to basically do the same thing as aim 2, but sub in cardiovascular factors. So we're looking at stroke, hypertension, diabetes, and smoking status there. I want to acknowledge this is a huge effort. There are lots of different interacting collaborators and teams. I work closely with Dr. Kobayashi at University of Michigan, as well as the HRS HCAP team in the US, which is really the parent study for all the HCAPs. That's led by Ken Lange and David Weir, as well as the Lassie Dodd team, which is led by Jin Cook Lee and her interviewer on the ground who trains everybody is Pranali. The ELSA HCAP is undergoing a leadership change, but Dorina Kadar knows where all the bodies are buried. And MEXCOG and Halsey and some psychometrics colleagues are also really important. So keep reading. Thank you. That's all I had. Got some questions in the chat. Let's see. Emma asks, what's the current question on study order for conducting item banking for standardization in the HCAPs? Are you planning to look at the sensitivity of these scores to order of studies? Not in this project, but in other projects, I have looked at. So the question is, when you're doing your item banking approach up here, does it matter what is study 1 versus what's study 5? Like, right now HRS HCAP is study 1 because I'm US centric and that's what I do. But what would happen if I made Lassie Dodd the first study? Well, in theory, your levels of cognition should vary, but I would not expect correlation, the overall correlations among resulting factor scores under one order versus another order to differ too greatly. I have looked at this in other studies, and that seems to be the case. There's a limitation to that, though, which is that you want to pick as your first study the study that has a lot of items and a lot of items that are shared with other studies. So HRS HCAP was the parent HCAP. They were the ones who were one of the earliest in the field in terms of administering their battery. And so everybody chose items that fed from the HRS HCAP. If I were to pick instead Halsey only has 31 items that I'm able to use. And so as a first study, I don't have a lot in common with HRS, with the United States and England. Yeah. Ravi asked, what was the R squared for the education variable in your linear regression models? You know, Ravi, that's a really great question. I can get back to you on that. It was not huge. I want to say it was on the order of like 20 or 30%. But you know, it's so I'm not trying to explain the variability in cross-sectional cognition as much as possible. I'm really looking at the proportion of cognition that is shared at the relationship between education and cognition. But I can get back to you with specific R squareds at some point. Any questions from you guys? Hi, Jen.
So this is very interesting, Alden, and I can't even begin to understand all of it, but I am very curious, and you have these countries with vastly different languages. So like you mentioned China,
Yeah.
right? So they don't have an alphabet like we think of as an alphabet. Like where do you even get started and that kind of thing? Like if you want, I'm guessing you can't do something like Trails A or Trails B, or can you?
Well, there are alternative. You have to talk about specifics, and you have to go test by test. So there are a cognitive test. Any cognitive test always relies on some sort of sensory input, right? So usually that sensory input could be language, it could be numbers, and we need to communicate at some fundamental level. So right now we are making a potentially strong assumption, because we have to. We're making an assumption that we can't look at language. We're assuming that that individual study leadership have done a decent job at translating instruments. So instead of Anna Thompson of South Boston, it might be Ravi Vardhan of North Bangalore or something. Whatever makes sense. They'll adapt the stories and the words to specific contexts. There are problems with that. So, something I didn't talk about in India, that study alone has translated their HCAP battery into 12 different languages, because they're in 12 different states. And so they've 13 different languages, because there's 12 states, each with its own language. And then there's Hindi. And so there's a word list test that includes words like butter and temple. And so in these translations, they've done their best to find the translation, the word in the language that means a similar thing. So ghee is the word for butter in Canada. But apparently in Kashmir, you can't say temple. It's culturally taboo. You don't want to say temple or church, or you don't want to refer to mosques or anything in Kashmir. So they had to sub in a different word. Is that comparable, or is it not? At the end of the day, for India in particular, we're doing some specific stuff on the side where we're looking at diff by country. And we are finding some things. And I've been on some calls with Pranali, who's the interviewer, who knows kind of who knows all the nitty gritty details about that cohort and how things were administered. And for example, one of the test items in the US and in MEXCOG is what's a prickly green plant that you find in the desert that works for us, because we know what a cactus is. You can't ask that in India. So that they sub in a question about coconuts. What's a nut that has milk on the inside? Well, as it turns out, people understand that around the coasts where coconut trees grow and in the south, but in New Delhi and in the hills and in the mountains, like around the Himalayas, they have no idea. They have no idea whether a coconut is a nut or a fruit. It's one or the other, but I can't remember what it is. So, I mean, that item is being dropped for wave 2. It just didn't work.
Well, I wonder, and I don't, if other people have questions, please don't let me.
Yeah.
All the time, but I'm curious, so has anyone thought about, hey, let's start from scratch? But I'm guessing most studies don't want to do that because they don't want to give up their longitudinal data they already have. But are there any efforts to make, and maybe it's not possible, a test that is universal across countries?
So it depends on the domain that you want to study. And this has been kind of like the holy grail of neuropsychological testing. So Jason Brandt just retired this year. He was a big neuropsychologist over in the School of Medicine at Hopkins. But he's been developing tests since the 1980s. Like he came up with the HVLT in 1987 in the TICS telephone interview for cognitive status. That was his in 1988. For the latter maybe decade of his career, he's been working on a test of language ability that is cross-culturally invariant. And the best thing he could figure out was body parts. So when you assess language ability, you're showing somebody a picture of a tree and you're asking, what's this? Or a picture of a house, what's this? Well, a house could be a mud hut, or it could be a wooden house or stone house, but body parts, this is pretty invariant. There are only so many items that are truly can be considered universal. There are translations, but there's always translation issues with certain items. For example, I could go on forever about some issues. Let's see, any good ones here. I've given all of my examples in here, but at the end of the day, if you are nitpicky enough, you can find a difference anywhere in any item. But at some point, you have to strike a balance. You have to compromise between what I call the lumpers and the splitters. So I work with some very detail-oriented neuropsychologists with Michelle on Fridays, and I'm a lumper. I'm happy to consider, so yeah, our wordless learning tasks were in some countries, they're only presented verbally because people can't read. And in the United States, they were presented verbally and in a written fashion. So in a way, it's easier in the US. I'm willing to say that those are comparable items, but all I'm able to convince my colleagues of is that these are at least tentative items. Okay, so this is where the distinction between tentative linking items and confident linking items comes in. It might be that these are linking items, but we're not going to go out and say we're absolutely confident yet. We're going to let the statistics tell us whether these tentative items are potentially linking items. So yeah, we're using expert advice, and then we're subjecting it to our statistical tests. And that's the best we can think of. Good question. David.
I had a question I think is a common tension that I experienced in 3D too. And you mentioned at the end of the day, you have all these latent factors, these continuous measures of cognitive functioning in different domains.
Yeah.
A lot of our colleagues, especially in clinical settings, they want categories. Like the MMSE is continuous, but it's unimpaired, mild, moderate, and severe. Are you under any pressure, or do you foresee any next step of this to come up with categories and cut points as to what's normal, mild, severely impaired, and things like that?
That's a really good question. Absolutely. So what I've been talking about is mostly results from this R01 that Lindsay and I are working on. But yeah, this one in yellow. There's this other R01 that for the gateway to global aging that we have, and one of the aims there is to develop clinical or cognitive impairment measures across all these HCAPs consonant with DSM-5 diagnostic classifications. So we're going to use these continuous cognitive measures. We also have measures of ADL and IADL functioning and informant ratings of how the participants are doing. And when you look at what the DSM-5 criteria are for major or minor neurocognitive impairment, they don't call it MCI and dementia anymore, you can imagine how you can make an algorithm. Now we've done this, I've been doing this on separately in La Ciudad, and Rich and Jones and Jennifer Manley have been doing it in HRS HCAP using a similar sort of hybrid neuropsychological approach where you develop a robust normative sample, a group that you're sure doesn't have any dementia, they never have a history of a stroke, no depression. They're a really strong sample. You get some norms on these, you get normative data on these for these continuous cognitive scores. And if somebody performs at 1 or 1.5 standard deviations below those norms, then we'll classify you as either with major or minor neurocognitive impairment. So, but that's a sort of some work that is planned under the Gateway Project. Yeah, that's coming out. And also individual cohorts, like the whole purpose of these HCAPs is to be able to look at prevalence of dementia cross-nationally. And so, you know, these individual HCAPs are invariably, I'm sure, working towards a similar goal. The reason for this RFA that went out back in like 2015 or 2014 was because way back then when I was a postdoc, Francis Collins was answering questions in the US Congress, and somebody asked him, how are we doing in the US with respect to dementia compared to other countries? And he couldn't answer the question because at the time, we didn't have these studies that were trying to administer batteries of tests, cognitive tests in the same way in a controlled setting across different countries in a representative fashion. That's a whole other thing. We've got convenience samples up the wazoo from a lot of places, but this is the first consolidated effort in the world to try to get a similar battery administered and scored in a similar fashion across all these different contexts. It's kind of like herding cats. And that's why I'm thankful that I'm just the little guy doing the data analysis. I don't have to do the actual, you know, study coordination. That's not the fun part. Okay.
Any other questions either here or from our online partners? All right, well, Alden, it was very interesting. Thank you again for presenting, and I'll invite all of you to come back 4 weeks from today, and hopefully we'll find a speaker between now and then. So thank you.
Thank you. Hi,
Great work, Alden.
thanks.
Move on.